Thank you everyone for coming to this session, that's Signing for Scale in Business Central Online. My name is Christian. I have Rayner and Maria with me. I want to start with a small history of Business Central Online. So it started in April 2016. Back then it was called Project Madeira, and it was the first SaaS version of NAV. 2 years later, we renamed it to Business Central Online. Sorry, some problems with it. 2 years later, I'll just talk. 2 years later, we renamed it to Business Central Online. And even after 2 years of development, it was still a pretty immature service in many ways. We didn't have any auto-scaling of VM capacity, very primitive load balancing, no auto-scaling of database, so sometimes customers ran into problems. But back then, only small customers dared go to Business Central Online. Now, fast forward 6 years to now, I would say we have a very mature service. We have advanced algorithms in many places, including auto-scale of VMs and database and advanced load balancing. We'll talk about that. We also have more relaxed limits. We accept more load coming in to the service. We'll also talk about that. And finally, we also see the results that more and more larger customers choose to go to Business Central Online. We'll also talk about that. The focus of this session is Business Central Online. So it's not the product as such that you can run on-prem, it's more how we run it in the cloud. So we will tell you how we designed it to handle large customers. We will have some recommendations for you that you can go and apply, but mainly the takeaway for you is going to be an understanding of how we designed our service. Most of the time, you shouldn't need to know these things. But once in a while, you are faced with a design problem, a scale problem, and hopefully it's nice to know how we designed it so that you can maybe take advantage of this. What we're going to start with is talk about how we manage our infrastructure, how we ensure there's enough capacity always, and how we load balance. And for that, I would like to welcome Rayner.
Thank you, Christian. So, that's a bold statement we put up there, right? So Microsoft promises unlimited infrastructure capacity. What does that mean? That means whatever load your customers bring to Business Central Online, we will manage to scale out to handle that load. But before we go into those details, let's just understand what we mean by scale, and let's review our architecture, right? So this is an extremely simplistic version of how we run our service. So you have a user that's maybe signing into a web browser, and their session then enters our compute tier. And we also have a database tier behind it. So what do we mean when we say scale, right? It's a very multifaceted word. It can mean multiple things. It could mean, for example, more users. So it's now hundreds of users, and we'll also show you some cases where it's thousands, right? It could also be API calls. So thousands of API calls and different characteristics, bursty traffic and sustained continuous traffic. It could also be data, tenant data, so very large databases. And some of you I know are wondering, how large is that? So stay tuned, we'll tell you. And it can mean a whole bunch of other things, right? So it could be more sales orders. It could be a lot of lines in these sales orders, more job queues, parallel job queues. So scale is a very different thing for the type of workloads that we're running. And what we're saying is that we would actually manage that. Whatever you bring, we will manage it. So let me explain what is our responsibility in all of this, right? So in the compute tier, we will handle scalability. We will make sure there's enough and sufficient capacity to run the workloads, right? And this is in terms of CPU, in terms of memory, and other characteristics. Same goes for the data tier. Like in terms of the compute that the database needs to have to run the workloads, we will ensure that there's sufficient capacity. And the takeaway for you is that Microsoft manages this hardware. You don't need to worry about scale. You don't need to worry about load balancing. We will take care of that. That is the promise. And there can be bottlenecks. And what I'm going to now talk about is how do we design to handle these bottlenecks and what are the algorithms that we run to manage this. So let's start with the compute tier. And in general, when you have a high volume workloads, our compute tier handles it very similarly, like how you would imagine. So we run our web server and the NSD service in a VM. And then obviously we want to handle more load, so we scale out. We have a lot more VMs. In front of this entire cluster of VMs, we've designed a load balancer. And what this one does is it gets an incoming session, and it has an algorithm which decides where this session should be directed. And typically, the cluster isn't too busy, right? So it could look like this, where there's some CPU load. And I'm just taking CPU as an example. We actually use different thresholds to decide how do we balance. But let's keep it simple and understand how it would work with CPU. And now imagine that one of our VMs is running at 60%, over 60% CPU. So that's just a threshold that we set. Keep in mind, at this point, nothing is really a problem, right? It's not a critical level. It's not the danger zone. That would be closer to 100%. That's when, the operating system needs to decide which threads to prioritize, et cetera, et cetera. So we want to keep these thresholds low enough that we try to catch the trends. And what our load balancing algorithm then does is it says, we're not going to send any new sessions to this VM, right? So we detect that it's potentially busy, and we're not going to overload it by sending more sessions. One thing to remember is that we actually don't move the sessions to another VM. So once it is running, we do not interrupt it. We say, hey, we think that it's going to finish its processing eventually, and then things will come back to normal. And in the meanwhile, we're going to direct new sessions to different VMs. Let's look at how this actually works. And we're going to use some data from our telemetry. We love telemetry at Microsoft, right? All our decisions are data-driven. So let's look at a cluster in the US, and it has 9 VMs. And this is about 5:35 our time, European time. So let's just see how this behaves. In this diagram, the illustration, each bar, vertical bar, represents the workload on a VM in terms of CPU usage. And on the y-axis, we've mapped the CPU usage percentage. So typically, and we're going to look at every minute instances of how things go, right? So when you look at this, it's not a lot of usage. There's some work going on some VMs, some are more busy than the other, but it's just fine. There's really no problems yet. Let's have a look at what happens in the next VM. Oh, so now 2 VMs are getting some sessions, and those sessions are doing some work, so the CPU is being used. Still not a problem at all. This is fine. This is okay, but we notice it. In the next minute, okay, so VM1 and VM2 are doing even more work. It's approaching our magic threshold for CPU usage. Again, nothing to be done at this point. But let's have a look now in the next minute. What happens is VM1 has crossed the threshold for 60% CPU. And if you remember what I showed from the diagram with the load balancer, is within this minute, our system has detected that the CPU usage has crossed 60% for one of the VMs, VM1. And the load balancer now identifies another VM to send new sessions to. And you can see that new VM is taking this load, right? So again, just to remind you, we don't kill any sessions in VM1. We let them run. They're doing their work. We don't want to interrupt it. But it's just new sessions will go to another VM because we don't want to overload this. And again, 60% is absolutely not a danger zone, right? It's fine. It's perfectly OK at this point. Let's see what happens in the next minute. So our thesis, which was that VM1, the processes and the sessions there will eventually finish what they're doing. And you can see that. The load now is going down in VM1. But the other VMs have actually picked up load, and they've crossed this threshold. And again, our load balancer kicks in and will not send new sessions to these VMs and directs them to the other 2 that you're now seeing are picking up the load. And as this goes on, eventually, the VMs, the sessions on those VMs that were busy finish doing the heavy workload stuff that they were doing. And we can see these trends for the busy VMs going down, and you can see the VMs that were assigned the new load picking up. And this goes on and on and on, and is fully automated, and we don't have to, there's no engineer who's looking and saying, hey, we need to switch configurations, none of that, right? Now you may be asking, hey, this cluster has 9 VMs, and this is not how the characteristics are always going to look, and that's correct. The 9 VMs could get busy. What happens then? How does a load balancer behave? Well, this is when we'll queue in our next warrior and our next defender, which is autoscale. And what we do is we'll scale the cluster out, right? So we get more VMs in. And to illustrate this, again, our very favorite telemetry and data, we really go into this. So this is a Swedish cluster with 24 VMs. And the diagram is depicted exactly like the previous one was. So each vertical bar is a VM, and we are trying to capture the CPU usage on average in a minute, right? Again, we've just put a little reminder for where our 60% threshold is, and now let's see how this behaves. So far, this is OK. And this is around 8 a.m. local time, so you can imagine users are going to come in and start logging into the system, right? OK, so some sessions that were assigned to some VMs are picking up. They're doing some work. At this point, you now know, and you're hopefully confident that the load balancer has detected that a few of these VMs have crossed the 60% CPU threshold. So they're going to direct new sessions to other VMs. You can also see those are picking up some load. No problems yet. This is fine. You can see, on average, the height of all the bars is going up. So that means all our VMs are getting a little busy. There's still not enough of them that are above our threshold, and absolutely none of these are danger zone yet, right? And this goes on, and we see that it's OK. And now we find an interesting line in our telemetry, which says, at this point, our balancing algorithm says, hey, I'm not freaking out yet, but there's a lot of busy VMs in this cluster, so let's scale out. And it immediately requests 3 VMs or something like that. So what we show you here is the number of VMs in the app service, or cluster, as we call it, and at the point at which we scale out, or we request new VMs. And now, how long does it take? Well, it varies, but in this case, right, from our telemetry, we can see that within 10 minutes, we had 3 new VMs provisioned, and the NST has started up, which is our runtime, and is ready to take in new sessions. So this is how we scale out. And at this point, again, I want to remind you that there's nothing in the danger zone. This is preemptive that we do these things, right? So we know that the VMs are busy, they're doing some work, and we are seeing the trends, but we want to make sure that this cluster is not starved, so we scale out. So this was the bottleneck in the compute tier. What about the database? Now, tenant databases are mapped one-to-one, so we can't add more databases, right? So what do? We will. We also monitor perf metrics here as well. And similar to the VMs, we look at CPU percentage usage, we look at data I/O percentage, and we look at log I/O and a few others. And depending on the insights we get from our telemetry, we experiment a bit. But we have a similar algorithm, right, where in an automated process, we're continuously monitoring these metrics for all of our databases. And the moment they cross a threshold, like 70%, then we say, hey, we need to scale up, because we can't add more databases here, so we increase the compute tier of these databases. And what does that mean? It means that we'll have more vCores available to this database, we have more worker threads, and better I/O characteristics. And eventually, because now there's more compute available, the average perf metric reduces, because it's a percentage of the total available. So this database is now, in our minds, considered, it's fine now. There's no danger anymore. And how do we decide what is the initial capacity, right? Because we need to pick, at the time an environment is created, we'd have no idea what kind of load characteristics is going to be there. So we have algorithms that do the initial allocation, and that's a fully automated process again, and it's based on 2 factors. One is whether the customer is paying or a trial, and the other one is whether it's a production or a sandbox environment. So we look at our telemetry and we try to gauge, like in 95% of the cases, trial customers are okay with this compute, and that's the initial. Similar, we look at production and we go like, hey, 99% of our production instances are perfectly fine with this, and we have the initial compute that's ready. What if after the environment is created, the database is now overloaded, right? Let's say companies grow, your customers will get bigger, they will start doing more fancy things that will take a lot more compute. So what happens if it gets overloaded? Again, same like the VMs, we have a fully automated process that is continuously monitoring all our paid production databases. And it's going to make sure that the moment any of our thresholds that we monitor cross a certain limit, then we scale that database up. And we look at this over a period of time, and we're pretty aggressive when we scale databases up, right? So our look-back windows are very short. The thresholds are not high. They're actually pretty low. We absolutely want to allow customers to run their processes without really worrying about these things. But we also don't want to over-provision, right? We want to be as efficient as we use our compute resources. So we do scale down, but keep in mind that we do this extremely cautiously and very carefully. So first of all, if a database has been upgraded or scaled up, we don't touch it for 45 days. We're like, okay, this was upgraded. There must have been some activity going on. Why 45? Because we also want to not get, mistakenly look at end of the month usage, right? So you want to include a little bit more. So for 45 days, we don't touch them. And then when we do decide to scale down, we see that the perf metrics that we are monitoring would be low enough that these databases would never be upgraded immediately, right? We want to avoid like ping pongs. So we do it super carefully, we do it super slowly, but we do it just to make sure that we run efficiently. But scaling up, that is super aggressive. The moment we see activity, the moment we see our perf metrics being used, we scale up. How does this look like in action? Again, our favorite telemetry. You're going to hear this a lot this session, so I hope you don't mind. So we look at the CPU usage, right? Just for example, of one of our databases. And again, we've put our 70% threshold over there. And we noticed that for some period of time, this is sustained. And eventually, our algorithm says, hey, this is not good. This customer's workload requires some more. So we scale up. And the scale up is almost instantaneous. There's no disruption. It's fully online. And there may be like a point-in-time connection that's broken, but our service is resilient enough to handle that. So the customer sees no disruption whatsoever. And the moment there's more compute available to this database, our perf metrics go down, because now there's more capacity available. And this is from our actual telemetry for one of our customers. So now, how good are we doing, right? Let's look at how many of our databases are overloaded, like the production ones. So we decided to look at a week in April, from the 1st to the 8th. And we wanted to plot how many of our production databases have been overloaded and for what percentage of the time. And almost all of our paid production environments were fine, not overloaded even more than 1% of the time. And that's great. We did notice that a few, like 0.2%, were overloaded more than 1% of the time. And in this period, we were actually quite surprised. We found 2 databases that were overloaded a little bit more. And this, we don't accept. So whenever we see cases like this through our alerts, we start investigating and try to figure out what happened. So let's summarize what we talked about, right? So Microsoft promises unlimited infrastructure capacity. I explained to you how the architecture is built, how we identify scalability bottlenecks in the compute tier, in the data tier. We add more VMs when we need, and we have an amazing load balancing algorithm that manages the sessions allocations within those VMs. We also add database capacity when we see that it is needed, and we do this aggressively to scale out. And then just because we want to be efficient, very carefully, we'll also scale down sometimes. But the main takeaway is that it's Microsoft's responsibility to handle this infrastructure. You don't have to worry about this. However, those of you who are smart notice the asterisk there, right? Because as we know, in life, like most things, are not really free. So there are some limits to when do we actually not do this? And I'm going to cue in Christian to tell you a little bit more about it.
Thanks very much. Yeah, so on the infrastructure side, we guarantee unlimited capacity. And also there is an asterisk, right? Because even there, it's probably not unlimited. But what we can say is we never actually stopped anybody. Like, there are some customers that use a lot of database capacity or VM capacity, and we've always, so far, just given them more capacity. But, of course, there could be a day where we say, that's too much. There are other limits, though. There are what we call operational limits. And these are documented. You can go on the website and see them. And when I looked at them the other day, I found 47 different limits documented. And just to give you a feel for what they are, I'm going to show 4 of them. So one is client connection limits. And what it says is the time during which a client can reconnect to the service after being disconnected. And the value is 10 minutes. So it means if you, for example, take your laptop, walk around the building, and you lose Wi-Fi connection for a while, you have up to 10 minutes to reconnect to the session that runs in the service. But if you don't connect, we might cancel that session so that it doesn't keep running. That's one limit. Another limit is company limit, the maximum number of companies that can be contained in one environment, and the value is 300. So you cannot have more than 300 companies in one environment. If you want more, you need more environments. Another limit, max file size, the maximum size of files that can be uploaded or downloaded from the service, 350 megabyte. So if you have larger files, we will reject uploads or downloads. And max execution timeout for queries, the maximum execution time that it can take to generate a query. If exceeded, the query will be cancelled. 30 minutes, right? Those are 4 out of the 47. What about something really interesting, like how many users we support? What's the limit on that? And we don't have any limits. So you can have 10 users, you can have 100 users, you can have 1,000 users, you can have 10,000 users. We don't have limits for that. Okay. What about how much they can do in the UI? Can they just open as many browsers as they want? Yeah, we don't have any limits on what they do in the UI. They can open as many browser tabs, browser windows as they want. They can click as many buttons, fill out as many fields, open, close as many pages as they want. We don't have any limits on that. So the UI, we kind of give unlimited capacity. What about on web services? So for web services, we do have limits, and actually they've changed recently for the better. So let's look at that. And this is how it was in the past. And in the past, it's like, 3-4 months ago. So back then, the limits were per environment. And one is the maximum number of OData v4 requests that can be processed at the same time. Requests that come in when this limit is exceeded will wait in a queue until a time slot becomes available. They wait in the queue until they time out after 8 minutes. And the value is 5. So we will process 5 in parallel. That was the limit. And the other one is the maximum number of simultaneous OData v4 requests, including processed and queued requests. And here, when this limit is exceeded, you will get 4 to 9 too many requests. And the value here is 100. Those were the old limits. Let me just illustrate more graphically how they worked. So we have our service, and we have an environment called my environment, and we have somebody or something that calls into it using the web service, OData web services. So let's imagine that this web service makes 8 concurrent HTTP requests right at the same time, 8 requests. What happens? As I explained, and what the documentation says, we will have some that get to run and some that get to be queued. And we will process 5 in parallel, so 3 will be queued up. And when one of the running ones finish, there will be room for one of the queued ones. That's how it works. Now, what happens if this other system sends another 100 requests right at the same time? What will happen? Well, they obviously can't run, so they have to be queued. But how many will be queued? That's where the second limit comes into play. Because we have 5 that were running, 2 that were queued already, and so there's only room for 93, right? Because the maximum of queued plus running was 100. So what about the remaining 7 ones? What happens to them? Well, you get 4 to 9 immediately. We reject them immediately. This is how it worked in the past. And there were some problems with that. The main problem with that can be illustrated like this. So we have a system here that sends a lot of requests, and they get to run and they get queued up because we can't keep up. They take too long to process each one of them, and we receive more than we can manage to process. And now we have another user in this system. This is John, and he's very important. He's the CEO, and he looks at his Power BI reports to see how the business is doing. And when he presses refresh in Power BI, it also sends requests into the service. So let's say he sends 8 or 6 requests in, right? What happens to them? Well, they get queued up, right? So they need to wait until they can get processed. Now, John is the very important person, right? He's not happy about this, so that's not good for John. But it can actually also be the other way around. Imagine this other system is a sort of a real-time system, like a checkout counter of some kind, like a point-of-sale system. And people are waiting to get the responses from that to buy stuff. Now, that is actually more important now, suddenly, than John's Power BI reports, right? So in general, we have 2 users here and one is more important than the other, and we shouldn't prioritize the wrong one. This was the main problem we wanted to solve, and this is how we solved it. So how do we solve it? So what we look at today is who is calling. So when John refreshes Power BI, the request will say that they are from John, right? There will be an authorization header that says, is John authenticating? And the other system will also be authenticating as a user, maybe Steve, or maybe better, an Entra application. Either way, we can see that they are different. And so what we're doing now already is we have a queue for both users, for every user. If there was a third user, we would have a queue for that user too. So the 6 requests that John made, where do they end up? They end up in his queue, and that means that 5 of them will be running immediately, and 1 will be queued up. So you see, with this approach, no users will wait for each other, which is what we wanted to achieve. There's a side effect here, if you can spot it. We will actually process more than 5 at the same time now. Like here already, we have 2 users, and we are processing 10 at a time. And if you have 5 users doing this, we will process 25 at a time. So we allow more throughput into the service than we did in the past. This was a side effect. So we looked at that, we considered it. Is that even safe to do? Can we handle that? Because the nature of web services is such that they can come all of a sudden. Like one moment there's nothing happening. The next second we get 100 requests. So they can come really quickly. Like unlike UI where people log in and they press a few buttons, like the growth there is more gradual. But for web services, it can come out of the blue. Can we handle it? And we consider that. We also changed some things, how we spread the load over our VMs, and said, let's do it. And so we did it, and it's going just fine. So the benefits, as I mentioned, that users don't block each other, the main thing, and the side effect, we allow more throughput. And if you also noticed, I didn't talk about you had to change anything on the consumer side, like the Power BI or the system didn't have to change anything. It was only on our side that we made some changes that allowed a different segmentation, and we allowed more to be processed at the same time. So you don't have to change anything in your code either, unless you want even more. And so this is where it may be nice to know how we implement things, because in some cases, perhaps you want to take advantage of this. of knowing this. So for example, I'll give you an example where it could make sense. So here's a system that makes a lot of calls, 100 requests per second. And they get queued up because the service cannot keep up. Like it processes 5 at a time, but they take too long, so the requests get queued up. And this is not good. So what can we do about this? First, let's do a mental exercise. Let's split the 100 into 2 times 50. Doesn't change anything, right? Still 100 requests being sent per second. They get queued up, they cannot keep up. But what we can do now is say, instead of authenticating as the same app in both cases, let's authenticate as a different intra-application. And now, suddenly, we get another queue. And so half of the requests will go there, and there will be less queuing. And if that's not good enough, let's add another intra-application. And then, then you solve it. And how you solve it in this system 1 can be round robin. So the first request uses app 1, the second request app 2, and the third request app 1 again, and the fourth request app 2. Or you can just use random, like every request, pick a random intra-application to authenticate with. Then it also ends up being evenly distributed. Okay, so with this, you can get more throughput, but I know what some of you are thinking now. And how do I know? Because I talked to some of you. You are probably thinking, why do I have to do tricks to get more throughput? Why don't we, Microsoft, just increase the number from 5 to 500? It's much easier, right? Then you don't have to change your system 1. And the answer to that is twofold. 1, our main goal was to avoid that 2 users block each other. And if we just increase the number, we don't necessarily solve that, because there can still be a system that just sends a lot of requests and fills up the queue, so others get blocked. Of course, it's less likely, but it can still happen. The other answer is a much longer answer, and I'm going to explain it to you just so we get it out, so you don't have to wonder. So first, an observation. One NST cannot handle 500, let's say, in parallel. It's just too much. As Rayner explained, we run on VMs. They have a certain number of cores, certain amount of memory. And we just cannot handle 500 calls in parallel on such a machine. So what we do is we spread the calls over multiple NSTs. So now consider this scenario. Let's say I make 2 sequential web service calls. The first call sets the name of an item to to London swivel chair. Okay, and the second call, I read the name. I would expect the name to be London swivel chair because I just said it. But since we spread the requests, imagine the first one that sets the value goes to one VM and the next request goes to another VM. Now you have 2 NSTs, and if you know about the NSTs, you know they have a cache. And so the first one will set it in the cache, it will set it in the database. The second NST might not yet have discovered that it has been changed in the database. There's a few seconds delay there. And so you might get what we call inconsistencies if we spread it like this. And we don't want to have those inconsistencies. We need to know when such 2 calls that are sequential are kind of related, so we can provide a consistent view. And the way we would give a consistent view is by sending them to the same NST. And we could here choose to say, put the burden on you, and you say, you must provide some header in the request to say that these 2 requests are in the same session. They have a header that says web service session 1, 2, 3, and then we would know to send them to the same NST. But that would be a burden for you, and we would actually break you, so that if you don't do it, you will start to see inconsistencies. So what we did instead was say kind of implicitly, a user is a session. So for every user, all of your requests will go to the same NST. Another user request might go to another NST, so that individually you would see consistent views. So that's how we solved it. This is a lot of explanation. I also tried to come up with a shorter version. We need to spread the web service calls over multiple NSTs. If we were to spread them randomly, we would get inconsistencies. So we choose to spread them by user, so each user gets a consistent view, and then they get sent to the same NST, and we can handle 5 calls for one user on a one NST. That's okay, but not 500. Okay, so there's another limit that I also want to talk about, and I call it fairness here. It's also like, if we reach this, it's kind of an extreme situation, and maybe there's something wrong, really. So it's also to sort of catch extreme cases. So here Steve has created a tool that makes 50 calls per second, which is kind of what we had before, almost. So in the first minute, it makes 3,000 calls. And in the second minute, it continues and makes another 3,000 calls. In the third minute, it wants to continue, but we say, no, that's too much. That's too much. 4 to 9, too many requests. And why is this? It's because there is another limit that we haven't talked about. So here are the new limits. These are per user, and you can see that we have the 5 that are running, the 100, which is the maximum combined, and also the 95, which is the derived number that can be queued up. And then there's a fourth one, the maximum number of OData v4 requests that can be submitted within a 5-minute sliding window. When this limit is exceeded, we get 4 to 9. So that's what Steve got here, right? He used up the 6,000 after in just 2 minutes. So in the third minute, we have to reject him. And the fourth minute, we reject him. 5th minute, 2. In the 6th minutes, the sliding window has moved beyond the first minute. And so now we start to let more requests in again. So the way to think about this is we allow very high bursts in a short time, 3,000 or 6,000 in 1 minute if you can manage that. But we won't let you sustain it. Like there's some problem probably if one user makes that many calls. But what if you really want to make so many calls? That's back to this way. Then you need to adapt a little bit and actually use multiple users, because then you can. Like, what would it take to support this many calls? It would take 3 different users. That would be enough. Then you could actually handle 50 calls per second, like this. Okay, so most of you should not be hit by this, but you can be queued up, things are running slower than they should. You can get 4 to 9s. But how do you know if you are impacted by this? It's very easy. If you have app insights enabled, which I hope you have, you can go and look for the RT8 event, which is the event we emit whenever we process an incoming web service call. And it has a few interesting columns. It has the response code. In this case, it's 200, which is not 4 to 9. So you know we didn't throttle you. And it has one more, which is the queue time, which is 0 in this case. So we didn't queue you up either. So it's super easy to see if you are impacted by this. Let's say you are impacted, then almost the first question is, who is impacted? Because now we have these per user limits. And here you can use this telemetry user ID that you have on the user card, which is not the real user ID, but another artificial one that you can set. And we will show it here. So if you do that, you will be able to see which user it is, and then you can change maybe something about that. So you might also be wondering, now that we allow more throughput, can we see on our side that the customers are getting more throughput? We have some results, and we will show them later when we talk about how large customers are today in our service. But now I want to move on to job queues, or scheduled tasks as they're called on the platform level. They also have limits, and they also changed recently. And the story is very, very similar to web services. And let me just quickly illustrate how they used to work. They used to work like this. You can have a maximum of 5 running at a time. And any other job queue entries that were ready to run would be queued up and processed, as soon as one was finished. And the new job queue limits, you'll never guess it. They are by user. So every user gets gets to run 5 at a time, and any others that they have will be queued up. So similar to web services, we will prevent users from blocking each other here, and we will also allow more overall throughput. And I think I know what some of you are thinking here as well, because at least I talked to some of you. In our companies, it's always the same user who schedules recurring job queues. So this change doesn't help at all. And to that, I have 2 things to say. One is, it will help in some cases. Like if your company is configured to use background posting, and Susan posts a sales order, there will be a job queue entry schedule as Susan. So there will be some spreading of users by user automatically out of the box. But yeah, for the recurring job queues, if you want to have more throughput, if you can see in your telemetry that you are being slowed down, yeah, then you might have to adapt and use your users more creatively. How do you know if you are being slowed down? The answer is again in the telemetry. So here we have an ALE25 event, which we emit whenever we start running a job queue entry. And there are 2 interesting, in this context, properties on this. One is the earliest start time. So this is the start time that you set, or if it's a recurring job, that was set. So this is like, ideally we should start right at that time. And then there's the timestamp, which is the time that we actually started. And then it's very easy to see how long time was in between. In this case, there were 2.5 seconds. Now, is 2.5 seconds acceptable? We think it is. Actually, when you schedule something to run in the background with a job queue, you are already indicating that this is an async operation that you push to the background so that you can continue running in the foreground. So kind of already indicating that you're not waiting for the result. That doesn't mean that we should run it, that it's okay that we run it an hour later or even 10 minutes later, in my opinion. But it's okay to not run it right at the moment. Maybe 10 seconds, maybe a minute later is also acceptable. For sure, 2.5 seconds, in our opinion, is perfectly fine. This telemetry also has the user ID, so you can see whose job queue entries are being delayed. And if you want to get an overall picture, I made this little query which plots all the job queue entry executions. So on the x-axis you have the time, and on the y-axis you have how much were they delayed in seconds. And each dot here represents 1 execution. And so you can see in my environment, almost all of them ran within 1 or 2 seconds of when they were supposed to run. But occasionally, some were delayed by 4, 6, 8, or 10 seconds. Right? So if you do the same plot against your customers, you can see if they're really impacted, if it's like several minutes delayed, and then maybe you should change something. We can also see on our side whether customers are benefiting from these higher throughput capabilities, and we will also show you that. Now that we are on the topic of job queues, one special case is you want to do some background or batch processing in job queues, which is a very common case. For example, you want to create and post sales orders in batch. Very, very common case. Suppose you have a company that has 100,000 subscribers, their customers, and every month you want to send out invoices to all of them. And imagine that every single invoice takes 1 second to create and post. Then it takes you 28 hours to go through all 100,000 invoices. So from the beginning to the end, 28 hours. Maybe this is perfectly acceptable for you, maybe it's not. If it's not, what can we do about it? And the main answer here is run them in parallel. Here we're focusing on the creation of the sales invoices. Let's look at the posting a little bit later. If you just parallelize, create multiple job queue entries like this, you will get more throughput. So here I have created 5 job queue entries. They are 99.9 identically configured. They are set to run on the 25th day of the month, and everything is the same. maybe accept the parameter string so that each job queue entry knows which customers to process, so they don't try to process the same customers, right? But other than that, they all run at the same time. And just with this simple trick alone, it should take you down to maybe 6 hours or less. And we can do this because creation of invoices, they can run in parallel just fine. There's no database logging, or very, very, very little at least. So it's not a problem to run them in parallel. So this is the main technique. So if you do this, there's still a couple of things that can go wrong. I just want to mention that you can take into account, and maybe you can do something about. So if you remember this slide that Rayner presented, we have a load balancer that looks at the load on the VMs, and then if a VM is above 60% or some other threshold on memory and other things, it will not send new sessions to that, but to other VMs. So what happens when we run the 5 job queue entries? We pick some VMs, maybe they go to the same VM, maybe they go 2 to one VM and 3 to another VM, but they stay on a VM for 6 hours, right? We don't move existing sessions, so once they start on a VM, they stay on the VM. So imagine now what happens if, let's say they all end up on VM5. What happens now if VM5, let's say after an hour, something makes it go to 100% CPU? We know what happens when the CPU goes to 100%, everything gets very slow. So we can't move the sessions, they're stuck there. So they are just gonna feel the pain, and they're gonna not run in 6 hours, they're gonna run in 10 hours or whatever. That's one problem. Another problem is, what if we decide to upgrade the NST on this VM, which we do maybe 2-3 times a week to push out the hot fixes, bug fixes that we have. So when we do this, we give existing sessions 50 minutes to finish what they're doing, which is not a problem for web service calls and background jobs mostly. But, and we also know, by the way, UA sessions, if you've ever seen this, we are refreshing the service. That's because of this, that we're giving a warning to the end user saying, hey, when the time is convenient for you, press refresh, and then you will be created a new session on a different VM. But any sessions that are still around after 15 minutes, which applies to those 5 job queue entries that we have here, we will cancel them. And it's not the end of the world for a job queue entry to be canceled, because you will see that it says it failed, there was an error, but if you have configured them to retry, they will just run again on a different VM, and they will pick up the customers that hadn't been processed, right? But still, you might be wondering, why did they fail? And is it my code? Are you wondering? No, it's because they were just restarted by us. Still, if you want to avoid that uncertainty, what can you do about that? So these 2 problems we can solve, and the way to solve them, in my mind, is you schedule them to run at most, let's say 10 minutes, at least less than 15 minutes. Like this. So we have some code here where you say, when they start to run, take current time plus 10 minutes, and then run until that time, or until there's no more work to do. Process the invoices until that time. But when we reach that time, if there's still more work to do, reschedule another job queue entry. And how does that look? That might look like this. So you take the currently executing job queue entry, and you create a new one, schedule a new one that is not recurring, and will start immediately. So if you do it like this, your job queue log entries will look something like this. So they are kind of grouped in 5. The first one at the bottom are the original ones, and you can see that one started at 2:53 p.m. and it ran for 10 minutes, and then it was recreated, or it created a new job queue entry that started at 3:03 p.m. and it also ran for 10 minutes, and then it restarted another one. So if you do this, you might see a lot of more log entries, right? But you will not see errors, and you will not be stuck on a VM that is overloaded. So that is something you can choose to do. So visually, we started with this, we parallelized, and if you want to break them up in smaller, you can do it like this, and and it looks like this. That was the creation of sales invoices. What about posting? Posting is the same, except there's more database logging. So in our logic for posting, we take logs, and this is a more problematic thing, because now we cannot parallelize to the same extent. They will be kind of synchronizing and not be able to run strictly in parallel. Still, there is something to be gained by parallelizing. So we work with one of our partners, Zaharia, and one of their customers, and they are now experimenting with running their processes in parallel. So they have an experiment where they run sequentially. It takes 6.5 hours. If they parallelize in 2 job queue entries, it takes 4 hours. And if they do it with 3 job queue entries, it takes 2.5 hours. These are representative numbers. The actual results vary more. But what you can see here is that it doesn't cut the time in half to parallelize in 2, but still there's a lot to be gained by parallelizing. And this is actually a technique that is generally recommended, right? Run things in parallel. If you, when I was preparing these slides, I was thinking about our laptops and our computers, right? They have CPUs, and back in the day, the CPUs got faster and faster every year, but at some point it got more difficult, right? And what did they do? They added more cores, and that is now the way you handle more, you give more capacity. So you can parallelize things. So what we do is we run sessions in parallel. I've talked about web services. We allow more to run in parallel. Job queues, we allow more to run in parallel. More users, well, that's more UI sessions. We run them in parallel. How do we do it? We spread them over more VMs. We just add VMs very, very easy for us now. We can just let them run. What about the database? We don't create more databases for your environment. So we have to scale that one up, but no worries. We're not close to hitting any limits there. And actually a fun bit, even for databases, we sometimes have a read-only replica that we send some of your the requests to. So it actually also, in some degree, parallelized. The main problem, though, for parallelism in Business Central, what is that? Locking. Database lock. It kills parallelism, right? So one main message here is, if you want to unlock, scale, avoid database locks. Like minimize it, because you cannot avoid it completely. So it can mean that you don't take exclusive locks. Maybe you use read committed if you have some tight code that you need to optimize. Or maybe you take smaller locks, like, for God's sake, don't use log table, because then you will be taking logs inadvertently. And when you take a log, maybe instead of taking it for a long period, narrow it down by moving things out of the period where you have the log, and make sure that this runs fast by having the right indexes on the database and so on. But those are some techniques. Not going to go into details right after this session. There's another session about new capability that we have, which is tri-state logging. Really recommend you to go and see that. Okay, but like the others, how do you know if you have a problem with database logs? Our story there is not as great, unfortunately, but you do have some queues. In telemetry, we have an event that fires whenever we have a log timeout. What is that? So it happens when you have one session that takes a log, another session wants to take the same log, and if it waits 30 seconds, that's when it says, I give up, I get timeout. Then we emit this. So it's a pretty extreme situation. Nevertheless, it happens. And so if you see this, it's a sign that you have a problem with the database logs. Another technique you can use here is the database logs page. You can just go into the product and open the database logs page. and then you will see right now, because that's what we do, we ask the database right now, who has which logs, who's waiting for logs. So in this case, we can see that Mr. Wilk has a log on the mixer table, and he was on the mixer list page when he took it. And we have Deborah. Deborah is waiting for a log on the mixer table. And so Deborah right now is slowed down by this. And if you press F5 here, we're going to ask the database again, what logs are there and who's waiting. And if Deborah's still there, she's waiting, right? So she's not happy. So this is another way to see, if the logs stay around for a long time, and where they are coming from, in which area they are, which table and which code. So so the main message here is try to avoid database logs. And now I would like to hand over to Rayner again, who will talk about how large our customers are today.
Thank you, Christian. So just to make sure we're on the page on what we've talked about so far, right? So we first started out with this promise that, hey, we offer almost unlimited infrastructure capacity. Then we explained what the architecture was and how do we handle, Microsoft handles bottlenecks in compute, in the data. Then we also said, hey, in some cases there could be some limits. Christian explained those, and he said, how could you try and work around them? But now, we don't really have those, for databases, we haven't really capped a limit, right? So let's see, what do we see in our telemetry for how big customers and what workloads are we seeing today? So we did a similar session back at Directions in 2022, and we thought it would be fun to, compare the numbers that we had back then and compare them with today. So first, let's just, remind people what we showed earlier. So first, in terms of number of records in various tables, right? So you could have 1,000 users in one environment, which is pretty big even back then. 1.4 million sales invoice header. We also had 7.6 million item ledger entries, and this was again 2 years ago. In terms of transactions, 5,400 sales orders posted in a day for one customer. Another customer had 58,100 lines in the posted sales order. Pretty cool numbers. In terms of tenant database sizes, back then, some of our biggest customers were 400 gigs, which we were very impressed by. And in terms of migrations from on-premise, we also saw some cases where 160 gigabytes were coming to the cloud, which we were also very cool. We were very happy about that. Then let's look at browser interactions. And just to remind you, a browser interaction is when a user is clicking around in the browser, they're entering some fields and they are tabbing between those fields. And also what it is not is when you're typing a character within a field, right? So typing a character is not a browser interaction. It's only when you tab out. So back then we saw about 312,000 in a day for one environment. And for some environments, we also saw 34,000 in an hour, which is about 10 per second. So you can imagine someone's sitting and clicking around 10 times in a second. And we saw some environments that had that kind of usage. And in terms of web services, one environment had 6 million in a day, which was wow. We also had some environments that had 77 per second on average in an hour. And we had some environments that did 8,400 in a minute, which is 140 per second on average, which was crazy. So we asked you, hey, what are you concerned about, right? And we wanted to know from the partner community, what were the challenges or what you were worried about? And we love the Business Central community. You guys are super active and immediately sent us some responses. And let's have a look at some of these. So Waldo said that he was currently worried about helping a customer with 120 people entering sales orders at the same time on SaaS. And it's very funny because he had his finger crossed, so wonder what he was thinking, wondering. Sales order creation. Christian talked a little bit about it, but there's two ways it could be done, either manually, or there could be some automated methods, like when synchronizing from a web shop, for example. And we have customers, and we can see this in telemetry, that are creating thousands of sale orders per hour. And one of them, for example, had about 8,000 sales orders in an hour with about 60,000 lines in total. We also had another customer that created about 4,000 in an hour, but 150,000 lines in total. So this is what we're actually seeing in our telemetry, right? And again, so although he was concerned, and then he said, now we are live. This was in June 24. And the overall experience is good. And there's an exclamation point. I wonder if he's surprised or excited. I don't know. And there's still quite some load on the item table, right? So the 600K items, and sometimes searching is a challenge. On average, 2 seconds. But he was okay with the amount. And we know that there are some challenges, and we're working on it, so stay tuned. Stefano had mentioned that, now not creation, but posting 100 invoices in an hour with about 7,000 rows per second, real world case. Camille tweeted us, and he said that, hey, again, posting 100K invoices per month must be done within 2 days. So let's look at what our customers are doing and how are they posting, right? So we already see that there's customers that, again, post thousands of sales invoices per hour. We also saw one customer, for example, that posted 5,000 in an hour, another that did half as many, so 2,500 in the same hour, but 120,000 lines in total. So this is already happening. Then we wanted to check with the number of users. And if you remember, we had 2 years ago about 1,000 users. So since we're SMB, most of our environments have fewer than 20, which is good. Thousands of environments actually have more than 100 users. And we already see this in telemetry. And we also have several that have more than 1,000 users. So this is very, very different from 2 years ago. What about database size? Most, again, since SMB, are less than 100 gigs, but we have many that are more than 100 gigabytes. And some are also massive. Like we have some customers that are 1.4 terabytes, and they are running. They're doing their work. So they haven't heard anything yet. And a lot of large databases are actually coming, and you guys are being super cool and helping them migrate from on-prem to SaaS. And in 1 month, we had one. Several were migrated that were more than 100 gigs. Some were even more than 250 gigs. And we actually have migrated customers with more than 500 gigabytes of tenant data. So these people are now coming to Business Central Online, and they're running. Let's talk about browser interactions. Just a reminder of what they are and what they are not. So just each character you type is not an interaction. It's when you tab out and click around and open, close, all those sorts of things. So 2 years ago, as I said, we saw about 10 per second on average. And then we looked at it today, and 300,000 a day, 36,000 in an hour. That looks oddly familiar. It's a little embarrassing. It's still 10 seconds on average. What's going on? Some explanation needed, right? So we dug into it because when we monitor our telemetry, we don't just leave it. We actually want to know why. We're a curious bunch. And we found out that, there's browser add-ins also sometimes. And they will just send some pings or send regular requests. But that is not a user-browser interaction. And we found that when we collected these numbers 2 years ago, we'd included them incorrectly. So now we fixed it. And we get 10 per second on average. So we think the previous numbers were quite inflated, but we still have the impression that it's doing really well. So if you now support as many as we incorrectly thought we did back then, but it's a good sign. And we're now monitoring it. Then again, if you're also as fascinated with telemetry as we are, we tried to look at one environment and looked at the browser interactions performed per minute. As you can see, during the weekdays, there's a lot of work, which is, just cool, and weekends, a little low, and Easter, well, people are away. This is just for fun. I just wanted to show you that we actually look at these things. Now let's look at job queues. Now, job queues, we actually did not have numbers from 2 years ago, but we did start tracking these from about 6 months ago. So back then, for example, we could see that there's some environments that do 350,000 in a day, which is great. Some environments that did 15,000 in an hour, 4 per second on average, and some even 300 in a minute and 5 per second on average. And Christian had promised you that we'll show you some numbers right after we made our changes. This is that moment. So what do we see today, which is 6 months later, after we made our changes to the service? We see that some environments have 15,000 in a day, and some have 18,000 an hour. But the coolest one is 16 per second on average. So that's gone up almost 3x, and people have not had to make any changes on your side, right? It's just when we changed our limits, when we changed our architecture, like we can't guarantee that these users are doing things differently, but we suspect that this just happened out of the box. What about web service calls? So again, we tracked some numbers back then, 140 per second on average. That was a number that we saw 2 years ago. We did our changes. Let's see what happened. And now we see some environments at 10 million web service calls in a day. We saw one environment that did 1 million in an hour, so 277 per second on average. And some even had 32,000 web service requests in 1 minute, which is a massive 540 per second on average. And this is, successful requests, so no throttling, no none of that. And that's almost 4 times of what we were seeing 2 years ago. So we don't know for a fact if they re-architected their solution to use multiple apps, as Christian said. But we also know that some customers will just have different users that are creating web services, and these are most likely the ones that immediately benefited when we changed our limits and changed our architecture. But they're great numbers. We really like it. If you want to know more about what can Business Central handle, we've actually documented this in the scalability for Business Central Online. And the same numbers that we have in these slides, you can actually find them out there as well. So if you ever are having conversations with some customers and you want to know, hey, can Business Central handle this? It's in here in our public documentation, so you can go and have a look at that. And now I just wanted to tell you guys a little bit about what we're working on in terms of scalability. And I wanted to ask you a question first. So, what do you think about the 80 gigabytes that we have and the 1 production and 3 sandbox environments? And what I'd like to know is, maybe clap if you love it. Is anyone happy? Do you love this? Do you think this is great? No? Well, we're reviewing this, right? So with the whole revamp of our service and our architecture and these user limits, etc., we are now looking at this as well, so stay tuned. We have some announcements that will be around the corner. And yep, we know what you want, so let's see. This is what we had planned for today, basically, and we wanted to tell you that we really want to support huge customers, huge workloads. We are designing our service for scale, so you don't have to worry about hardware, you don't have to worry about capacity. We have amazing auto-scale load balancing algorithms, and we learn as well, so we look at telemetry, and I hope you're convinced that we look at it really closely to try and see, what can we improve, what can we do better. And infrastructure is Microsoft's responsibility. And we add capacity as needed, and we've told you the cases where there are some limits, especially around web services and job queues. We've also told you how to handle them, how we do it, so you can better design your solutions as well. If you need higher throughput, what could you do? And the main takeaway is to parallelize and chunk work into smaller batches, right? So avoid these long-running sessions. Now that you know how we do the load balancing and auto-scale, you know that you don't want to do tricks to keep sessions alive, for example. Because the moment we can, say that, hey, this VM is overloaded, go here, it gives us the freedom to do these things on our side. And the main takeaway, as Christian has also been mentioning, and a lot of other sessions you've been hearing about so far at Tech Days, minimize database locking. The larger and larger customers are coming to Business Central Online. We showed you some numbers, we are hearing from you, you're sharing your stories with us, and it's amazing. So we can handle these, and we are getting very, very mature as a service, and we're very confident with how things work now. That's all we had to present, and I also have Christian and Maria who will help with some Q&A, so let's have some questions. Yeah. Yes, we have one here. I'll give you this.
Yeah, one question to the scaling. Can we track when you scale up? So can we get that in telemetry as well?
We've been thinking about this, but in general, we want it to be something you don't have to worry about at all. So it has to be seamless, right? So as long as we're doing our job well, you should never have to know what is happening. So if we know, and these things happen automatically, and thousands of databases are being monitored and scaled up and adding more capacity. So we really don't know if that would be too useful to you, but we do have all the other telemetry available in App Insights, which we thought might be more actionable in that sense. And we have alerts, right? So we know that software can have bugs. We have alerts that tell us when something's wrong, and then we immediately go and fix it. So this is, as we said, this is something that we will like to worry about, and hopefully you don't have to worry so much about.
But we might want to give you actually some signal if things are not that good and we know about it. So we would like maybe from partner telemetry or TAC in some way, your session, your environments, maybe, they're not doing. So we're actually looking into that based on feedback.
Okay, thank you.
Yeah, third. Who's next? And you get this one.
I want to ask you about this per user limits. Mm-hmm. Is this already applied to all regions, or you're still rollouting it?
It's for all already. The web services, I think they are only available for newer versions. So if you are stuck on an old version, maybe.
No, I mean that because till now it was per environment limits, and now per user. So it's rollouted for every environment. And my second question is, when I have a tenant with 6 production environments and I have a user that works in all of them, and also I have sandboxes, etc., is this limit per user per environment, or is per user per tenant?
Good question. It is per user per environment. So they get the same limits repetitively in all the environments.
And the same limits apply for the sandboxes as well?
Also that. You had one?
Wanted to ask about, you spoke earlier about scaling the paid environment.
Yeah.
Is there less power behind the sandboxes?
So there's the compute tier and there's the database tier. And the compute tier, same size VMs, we scale them the same. The database is the difference. We don't scale it there. So if you have a lot of work going on in your sandbox and you hit the limit, tough luck. We don't add more capacity there. Okay, let's see.
You showed us that there's an auto-scaling functionality, but if I know there will come in a massive load, can I preemptively request it somehow?
Yeah, it's a great question, and we get it a lot, and there's really no need. Because for the VM capacity, if you look at the Swedish cluster there with 24 VMs that were around 60%, consider these 40% as our buffer. We have an immense amount of buffer in these clusters, so we will have enough capacity for almost any workload that comes in. Yeah. Also on the database, we react very quickly. So there's really no need to plan ahead here for us.
We had the issue when there was some pre-sales, and we knew there were probably 100,000 users which will order something, and then even if it's scaling out, you showed us it needs about 10 minutes to do so.
Yeah.
So that would take too long, actually.
And that's why actually we continue improving this area, because what we want to achieve is like, full elasticity. When you have high birds, we can go as fast as we can, even faster than the 10 minutes.
Yeah, but just reiterating what Christian said, it's we don't wait till it's in the danger zone. So we preempt based on the patterns that we're seeing, and the algorithms are always looking at this. So we don't wait till it's that late. So yeah, maybe one from this side.
Yeah, exactly.
Hi, I have a question about the read scale-out database. So, for example, for our client, we have created API queries with read access intent to read only. The users are complaining that sometimes it's slow Business Central usage. My hunch is that it's probably maybe Power BI during the day making queries. Is that something that can, in some cases, not be reading the replica database and instead going into the production database?
Yeah, that's perfectly possible. Some of your environments don't have a read-only replica. Some only have the primary one. So it's only once we see a problem that we then start to do these things and add a read-only replica. So there might not even be one. And even if there is one, you have to also design a little bit for it, right? You have to annotate the code and say this should go to the read-only replica.
But that's something that we have already.
Okay.
But is it also, does the API queries go through all the same NSTs, so as the users, so can that also affect?
Yes, they go through the same, and in principle it can affect, but it shouldn't, right? Because as we explained, we have enough capacity on these VMs, and it's rare that they get high CPU and low memory and things like that. So it shouldn't be a problem.
And I mean, you have also a bit of control how you use the replicas with using the read-only intent. But then I also heard these days some feedback about maybe we can surface in partner telemetry when we have the long-running queries, if it goes to the replica or the main. I don't know yet, but we will look into that as well.
But with the long-running queries, we get that into the telemetry. Does that tell anything about, is it from the, no?
No, that's what
I'm saying.
Yeah.
So today you can look and see which are the queries which are slow, but we will not show you if it's going to the primary or to one of the replicas.
Yeah. Okay.
Yeah.
All right. What's next?
Oh, sorry.
Hello. You have said that Business Central is growing and there are some huge customers already and it's going to grow even more. And as we know, Microsoft has some other products that are not the same, obviously, but that are overlapping, like F&O. And we've had a customer who has been steered towards F&O, so I would like to ask you how are you differentiating or prioritizing one over the other?
That's a good question. I mean, you should look at what you need, I would say. I don't think we are pushing one over the other. Like we're saying what we support. And what we're saying now, for example, in this presentation is we support large customers, maybe F&O, for example, supports even larger, I don't know, probably. So you should just take what is appropriate for the customer.
And I think it's also the specific scenarios you are interested in, to, intercompany maybe,
Exactly.
So you need to look at the processes. And I think, I also got this question earlier, and I would really like to revisit what guidance we have out there, BC versus F&O. So we'll follow up on that.
Thank you.
Oh, some over here. Oh, thank you first.
Hello, thank you for explaining that job queue entries are cancelled when they are running during update period. That was one puzzled us for a long time. But something we noticed was that when this cancellation happens, often the job queue entry gets stuck in still running, but the task behind it is cancelled. and when you open the job queue entries page, it does a find stale job queue entry and tries to restart it very sneakily, so nobody sees. But if you open it as a delegated administrator, you don't have permission to start job queue entries. So I was asking, maybe it's sort of related, but if this can be auto-run regularly.
I think we've
somehow.
had a history of having somewhat unreliable job queues, right? But if there's still bugs around, it seems like we need to look at it. There was one over here.
So, with the one production and free sandbox systems, how do you suggest we handle testing and bug fixing with customer data? Because downloading is not really an option, and creating a new sandbox can be problematic when there is sandboxes in use, and the developer sandbox, can we somehow transfer customer data into these, or what's the suggestion to handle these things?
So the story today, which we know of, is problematic in many cases. Is you copy to sandbox and then you experiment with that, but it can be a problem because maybe you're using all your sandboxes already, or maybe you don't have enough storage, and so on. So that's what Rayner was saying, that we are looking at improving, and there will be some announcement in the fall probably about improvements there that I'm sure you will like.
Okay,
I would like to know, actually, still from this room, how many people would like more storage or environment?
Yeah.
Okay, good to know.
That's good.
So at the moment there is no solution to...
You can buy more, right? That's the thing,
yes,
right?
so,
so
the only solution is to buy a second production. Okay,
or more storage if that's what is limiting you.
But yeah, again, stay tuned. Something will come for 25X.
Yeah, I have a question regarding that you talked about the parallelizing and concurrent users for the job queue entries. Is that also applying for the on-premise solution, that you have 5 concurrent sessions for the users when you're using the job queue?
No, that is something we configure in our service.
Okay, so that's...
you can run more on-prem.
You can run more on-prem.
The implementation is a bit different, so it's only for the BC Online.
But is it still that if you use different users, that would actually take 5 jobs or only 1 job per NST?
Do you know? But it's definitely
nothing changed for
it's
the
not
on-prem.
nothing changed, and it's not doing the per user thing at all, I think, on-prem.
Yeah. And it's whatever settings you see in the NST configuration, those are the settings that are there. So what we've done here is, like, we have, like a bunch of services that actually do this orchestration. So we've changed how that happens online.
Okay.
Yeah.
Perfect.
Are fresh NSTs handled differently when the compute tier scales out? Is there some kind of delay when redirecting users to the fresh NSTs? Because something I've experienced is that some users were redirected to the new NST and there was some loading time still required because it's still warming up.
Yeah, that can be that. So what Rayner showed is after approximately 10 minutes, the new VM and the NST is ready to accept new sessions. But the first sessions might trigger loading of the base app and other things, and it may be a little bit slow.
Yeah, there are different levels of cache, so your new machine, the NST cache will not be the same, but of course some others will. Yeah.
You mentioned also caches in between the NSTs. What's the period where is the cache is synchronized in between the NSTs?
Do you remember?
Sometimes
what we do back in our service is we use Azure Service Bus, just as a detail. And so when the NSTs, when one NST makes some changes, it kind of waits a little bit, a few seconds, that's just what I don't remember. But then it broadcasts it to the other NSTs, and so they know, aha, okay, I better refresh my cache. But I don't exactly remember. It's a few seconds, something like that.
You can always go to the logging session and ask Matt and Torben, both will know for sure.
Any more questions?
We have one at the back.
Oh, wow. What? Okay.
Thanks.
Yeah.
So we had a couple of cases of customers which basically need to work with the system 24/7 and heavily rely on job queues that run in sequence, where subsequent steps relies on the result of previous steps. So, and a couple of times the overnight updates kind of mess up with the whole flow because they're not really, we don't have much control on them because we cannot set a window, we cannot, and the window that it's available is kind of large, 6 hours, I think, something like this. Is there any plan in the future to have more control on this parameter, sort of reducing it for the hotfixes, or?
I know it's coming from time to time as a request, but right now actively not. But maybe, give us more feedback on this and we would revisit the story.
Okay.
Yeah, maybe throw it on BC ideas and see if there's enough votes, then it might force us to look at it quicker. But yeah.
Okay, thanks.
No plans as of right now. No.
We actually have a client that has an issue with this as well, and they fixed that by enforcing the updates. Sorry. We have a client that had the issue as well, and we fixed that by enforcing the updates by ticking the box that says you can run it outside of the hours, so that way we can kind of control when the updating happens. Mm-hmm. So that might be something that you can use for this.
Any more?
BCPT can run only on sandboxes. So the main problem in using this for the SaaS is that you don't scale behind the scenes the databases. So it is not reliable. We are heavily using for the on-premises, but for the online, this needs to be done on the production system.
Yeah, that's perfectly valid feedback. That if you had a production environment, it might actually bump up the database capacity, which it won't do, as we explained, for sandboxes. So you will get better results once you run in real production versus what you are testing. Yeah, it's valid feedback.
And I would love also to see more feedback on this, because the more you actually push these ideas and vote on those, we can take a look more. Because it's also not the first time we discussed a bit, should we revisit the config story for Sandbox?
Cool. Okay, let's take the last one over there.
Thank you. We're an ISV, and we've recently, or a year ago, created a SaaS version of that. And we're migrating a lot of customers up to the cloud, or we're planning on that. And I've got a large customer where I'm doing a proof of concept. So we're looking at getting the data into Azure SQL first, and we're looking to do the proof of concept on a production SaaS environment for the performance on the SQL that you spoke about. But the question is there anything in particular we should look out for or investigate during that proof of concept that you could recommend?
Yeah, so when you want to test out things, the best approach is to use the performance toolkit that was mentioned before, because that way you can simulate the reload and see if it's working as you expect it to. If the UI is responsive, the job queues are being processed, all of that.
More to do with the data migration, to be honest.
What about that?
I'm concerned that we might not be able to run it in the weekend, for instance.
So the migration to the cloud of the database, I mean, you can the way it works is right. It takes an initial copy of your database, and then you can do incremental changes from then on, and you can keep running like that and synchronize the two environments. so that once you're ready to finally move, you can do the last incremental migration, which shouldn't take a long time.
I see.
So in principle, it should be perfectly possible to do in a short time, that last piece. All right, time's up. Thank you very much for coming to our session.
Thank you.
Yeah.